Bismillahirrahmanirrahim. Welcome to International Research Class. For our discussion today, we will discuss about the one's probability modelings, namely three parameters, quasi-gamma distribution, and with properties and the application. Our discussion today based on the one's research article that published in the international journal, namely Pakistan Journal of the Statistics and Operation Research, with the title Three Parameters Quasi-Gamma Distribution and with Properties and Application. This research article published on the 2022. I think this is new, the article. Okay. In this recent article, we can find the density function for the three-parameter quasi-gamma distribution, like in the equation 2.1. In the equation 2.1, we can find the probability density function, the three-parameter quasi-gamma distribution. This question have this question have the three parameters such as alpha, theta, and k. Okay. In this research article, we can find the log likelihood for the three parameter quasi gamma distribution, like in the equation x1. In the equation x1, we can find the log likelihood. Okay. From this equation, automatically we can use the optim in the R software to solve the problem in the estimate the parameter. Okay. According to this research article, like in the data set 1, we have the 69 data carbon fibers. Based on this data, we will create the R programming to estimate the parameter using the R software. Okay. We will try to comparison the parameters that we are create by ourselves, and then we comparison with the parameter like in the table 91. Okay, in the table 91, we can find for the data set 1 have the parameter theta 0.10 and alpha 2.4 and k 1.6. This is according to the research article. So that why for our discussion today, we create our R programming and we run our program, and the estimate the parameter, we will make comparison with the parameter in this research article. Okay, let's open our R programming. Okay, this one. In this R software, we have put the data like in the data set 1. We give the name X. X is mean the 69 data. Okay. And then N is the length of X. So when we are trying to use the optim to the estimate the parameter, of course, we must use the log likelihood. The log likelihood, we are likely in this recent article, like in the equation x.2, there is the log likelihood. So we just only try to create the R program based on the equation in the x.1, like this one. Okay, like this one. This is one is log likelihood for the three parameters quasi gamma distribution. Okay, this one. Okay, we just only try to max our programming based on the equation in the x.2 equation. After we create the log likelihood, we use the optim with the initial value. For the parameter 1 is theta, parameter 2 for the alpha, and parameter 3 for the k. After we have success to find or the estimate the parameter, we try to use the density plot to make sure the parameters is very good to capture the histogram the data. So that's why we need the xi. Xi is the sequence 0 until the 2 multiple maximum data with the jumps 0.1. Okay, after that, we must use the density function of the 3 parameter quasi gamma distribution like in the equation 2.1 in the recent article, we give name FQGM. So after that, we have Xi, we have the density function. So we try to use the comparison, the histogram data, and the lines or the curve of the density function. Okay, let's run our program. Run our program. Okay, we run program. So we check in the console. Okay, our program is success to be run. No problem. Our programming is success to the estimate parameter. Okay, we just only try to type M. We try to type only M, Q, G, M to find the parameter. This is for the this is one for the theta, this one for the alpha, this one is for the k. So it's mean our programming success to the estimate the parameter and they have the same value with the parameter in the recent article. So our discussion today is success to prove the our optim program success to find the estimate the parameter. Okay. After we have the parameter, we try to make the density plot. Okay, we just run our program. Okay, theta for the parameter 1, alpha for the parameter 2, k for the parameter 3. We run our program. Okay. So you can check here. The red line, it means this curve, the curve produced by the density function. And the histogram or bar graphic, it means from the real data. So we can see here, can see the red line is can capture the histogram. It means the 3-meter quasi-gamma distribution is the best model for the 69 data carbon fiber. Okay, 3 parameter gamma. Oh, no. We change no gamma. We change here, not gamma, but the 3 parameter quasi gamma. Quasi gamma distribution. Okay, we runs once again. Runs again. Okay, you can check here. The red one is the curve produced by the density function, and the histogram from the real data. Okay. For our discussion today, we have proof our optim is very, very good to use to the estimate the parameter. You only must understand what is the likelihood, log likelihood, the density function. After you understand about the log likelihood, you just use the optim, and then you can find the parameter that you need. Okay, I think this is good discussion today. Okay, we will try to discuss in the another time. Radio Yendra and Radio Institute. See you again. Assalamualaikum warahmatullahi wabarakatuh.